Hi everybody, welcome back to Qt series with C++ and CMake. By the end of the series, you'll be familiar with Qt6 framework, Qt which is mostly used nowadays for real software, and minimum required CMake, so you can make your apps. This episode is an introduction. I will show you how to create an empty project and discuss the project structure. Also, the episode will cover the use of some basic input and output that Qt framework provides us to show info in the console. So let's just dive right in. So here's my Qt creator. I expect you to have Qt creator downloaded. There are tons of videos out there on how to do that, and the installation process is not such a philosophy. So I know that you can do it without my help. As you can see, I already have some projects, don't worry about it. When you first open your editor, you can see so many different buttons, but don't worry, we'll get used to it. Just for now, we want to create a project, so let's click on the Create Project. As you can see here, you have a bunch of options, but we are interested in application Qt and the Qt console application. Just for now, we don't want to jump right into Qt Quick, and I want you to build a good basement in just a framework. So let's choose it. You can choose whatever location you want and specify the name of your project. Let's say I'll name it tutorial 1. I already have that. So video, but you can choose whatever name you want. You can also set it as default project location where you choose, and go ahead and click next. And here we want to choose CMake as a build system because CMake is mostly widely used nowadays. We skip the translation file because for now we don't want it, and in the kit selector, just select all, because you might want to use it in the future. I mean, debug mode is really useful sometimes. Okay, let's hit next. And here in the version control, we also not gonna choose any version control. I mean, any. We have only Git. If you want, you can. But it's the introduction episode, so I won't do it. So let's finish and create our project. After project is successfully created, you can see your main CPP file with the main function. I won't explain very basic stuff about C++, such as what is functions, loops, and variables, because I hope you have some knowledge about this beautiful language. I will mostly focus on Qt framework and what is really happening. At the beginning of main function, you have Qt core application that is used to event loop management, lifecycle, and centralized object management. If you don't really understand what that means, for now, don't worry. We will discuss these topics in the future videos, and I will do my best so you understand it. So here really we just create a variable that manages all application. And here notice some interesting thing. We return a.exec method. What? As you remember, in C++, in most cases, we return 0, just like that, at the end of the main function, if everything is okay, or some status code, if we want to notify about problem. But here we call exec method, and you probably wonder what it even doing. See, Qt framework is mostly used for desktop apps, and every such app needs to have an infinite loop inside, so it can manage timers, events, or other input. Even though we have a console app that should have a start and end, we also need to add it to work with the framework functionality, such as signals and slots, for example, that we will discuss, of course, in future episodes. As you can see, there is also a comment. If you read it, here it says, call a.quit or a.exit to quit the application. And it also gives us example that we will test later, and I will show you how it really works. In the project, as you can see here, we have also cmakelist.txt file. Here we have it. If you are not familiar with CMake, it basically helps us build projects for different compilers and environments by providing simple configurations, calling functions like here, what you see. By series going, we will see how that file changes, but just for now you should know that we can provide some info for Qt with the set function. Like here we can set, for example, language standard or something to relate or something, some another stuff. And add our files with the functions like add executable. There are other functions, and I will show it to you as the series going. I know that you're probably a bit tired of my talking, but trust me, as more carefully you listen, as fewer problems you'll encounter in the future. Not every tutorial will explain you bit by bit what is happening. And now let's go to the main CPP file. And we have very responsible work to do. We have to write a first hello world program and understand what is happening under the hood. When you develop Qt app, you can use standard CPP library. For example, IOStream, like you can write include IOStream. It's not an error or something to print data. But Qt has its own mechanisms, and it is recommended to use it rather than standard C++ libraries. I mean, that is why we call Qt framework, because framework is like container with a bunch of different libraries to make everything you want. Okay. So I started it and then deleted. Sorry. Instead of IOStream, we'll include Qt6 stream. It's something similar, okay, but in Qt. It will give us a way to input and output data in the console. At the beginning, I will show you the harder way to do it, and then the easier one that you'll mostly use in the next episodes. Before we will dive into Qt Quick, and you'll display it in your on your interface. The longer way and the harder it depends on the thing that you have to create Qtext stream object passing parameter in the constructor. So I won't delete comments for now, and let's see how you can create that object. So as a normal C++, you write the type, then name. Let's firstly make input stream, then output stream. Stream. And here it is important thing that we have to show to show in program that we want to have input stream. Here we write std in. Okay, and then let's copy it and make the same just with the output stream, and it's gonna be std out. The very important thing here is that std in and std out don't actually have anything related to the that std namespace that you probably write it earlier, and you write like std cout and all that stuff. It's not have anything related to it. What you pass is just macros. As you can see, if you hover your mouse over, you see it's macro. And that macro is and those macros are representing the pointers to the file structure. I mean, the structure of the type file, like this. And the structure allows you to read and write input. If you, as I say, if you hover your mouse over, you can see it. If you want, you can dive into it, or you can just trust me, but because like how you like. Then, as you created it, you can write something similar to what you made previously. For example, output data, and we can output it. Let's say enter your username. For example, we sign in some console app. Okay. And then what we want to do is read that line that the user want to provide us. And for now, let's quickly include type that we want to use. It's QString. I mean, for now, you can think of QString just as normal string. Of course, we will later discuss it more deeply, but for now, it's just string, okay? Username equals to, and here important thing, but I mean, it's similar to what you done in just C++ with the IOStream. And here's get input stream, sorry, read line. If you want, you can specify the maximum length of string that you read, or you can just pass it and read the string that we have from user. And then it's logical that we want to output stream, let's say hello username. Okay. Now, if you try to run your app, let's try. As you see here, application output, and you really get nothing. I mean, even the terminal didn't open it. What is happening? So we have a couple of mistakes, and the first one is that if you work with console and want to see something in console, then we have to configure out our project. Let's go to projects, here run, and check the run in terminal. Okay, then let's go to edit. Let's run it one more time. As you see, the terminal opened, but we don't have that output. There is nothing. Okay, we have one more mistake, and it is more interesting. I am not sure if you remember it from your maybe some C++ tutorials, but every stream in C++ works like a stream and could be broken. So we have to add one interesting line after every output. Output stream flush. So after we flush it, we kind of fixed it. And here also we have to add, if you try to run, let's try, as you see it builds. And we have here, enter your username, I don't know, user1, hello user1. Everything works fine and properly. And that is fine. As you see, it took us a bit of time to write output functionality. As I mentioned previously, there is easier and faster way. Instead of flushing and creating objects, instead of we can use QInfo. or it has another types, for example QDebug, but for now we will use QInfo. What is that? So first things first, we have to include it. I mean, why I could write it? Because I included QStream, and it has already that library, but in normal world you have to include QDebug. So okay, let's write it. Let's remove object from our code and then just write like this, and I will explain you why it works. Oh, sorry, I deleted all text and I don't want to write it one more time, so I will just copy and paste, and here it's similar. I don't want to write it one more time, so I will copy and paste. Let's quickly run just to make sure it works, and I will explain you what is happening here. Can make it more beautiful like this. Enter your name, QE, and as you see it very nicely outputs for us. So what is really happening is that QInfo is really macro. It's also macro, as you see, and it returns us just a temporary stream-like object for logging, and it makes everything that is necessary instead of us, so you can just output data and don't care about nothing. As I mentioned at the beginning of the episode, we call a.exec method to run application loop. Instead, we can run it for some time and then quit. Let's use the suggestion in the comment section and include QTimer, and then copy and paste, add single shot at the beginning of the our function. I won't explain for now what is single shot, but it's like after 5 seconds that function quit will be called. Okay, I will explain it more deeply in the later episodes. Okay, and now I will left all code here. Let's remove comments, we don't want it anymore. And if I run it, okay, let's save all. It builds. Let's wait a second. If I run it, I will wait 5 seconds, okay? I won't enter my username, just wait 5 seconds. I think 5 seconds is gone. Let's write something. No, it was just, it was like 5 seconds, okay. Let's put 1 instead, because I want to show it for you. I'm not patient, as you see. Okay, 1 second is left. If I write something, you see, before I get my second output, I get here that message. Process exited with code 0. So our program like quitted, and then we got our output, and that's how it works. So we can quit program before the end. We'll discuss timer and bunch of interesting stuff in the next episodes, but for now I think it is enough. So thanks you for watching, and don't forget to stay motivated and learn Qt. Hi everybody, in today's episode we are going to discuss probably the most essential topics in the Qt framework, or more precisely QObject class and the meta object compiler. So listen carefully and let's dive in. I want to start with a little bit of explaining, and then we'll write an example program in the editor. The first thing I should say about the QObject class is that it is a herd of framework. It means that nearly everything in Qt inherits QObject inside. As you see here, it is the list of classes inherited by QObject. And as you see, it's like huge amount of classes. The standard C++ object model provides very efficient runtime support for the object paradigm. But the thing is, classes that don't have some basement is inflexible in certain problem domains. GUI programming is a domain that requires both runtime efficiency and a high level of flexibility. This central feature with QObject opens us very useful features in Qt to develop GUI systems. Now let me draw a bit and explain the advantages. First and foremost, the advantage is signals and slots. We will discuss it more deeply later, but for now, just think of that as if you have, for example, button, that is button, and I don't know, a mail sender, for example, the thing that sends emails, mail sender. And you want to add some functionality so that when you click button, sender gets something and can send the mail, for example. And that is what signals and signals and slots are actually used for. So when button is clicked, the signal that was previously connected to the slot is emitted. For example, you have here a slot. Let me move it a bit. A slot in the mail sender. Let's put it inside. And here you have signal. And when button is clicked, someone pressed it, click it, then you emitting, I don't want to write it, but you understand, you emitting the signal, and previously, before you emit it, you should connect a slot to the signal. And after emitting, every slot gonna get that signal that you have to make everything that in the slot, because slot is we can say that slot is a method or function that you just write and it's later called. Second advantage, and very important one, is that objects organize themselves in object trees. Similarly to signals and slots, we will discuss that more deeply later. But for now, you should understand that all objects, for example, one object, second object, like objects, that's all some objects that is inherited from, of course, QObject. Build the tree, so we can put like parent and child relationships, so that it automatically deletes its children in its destructor, I mean that object. It allows to avoid memory leaks and strongly helps us to solve one of the most problematic parts of C++ language. And for example, here, let's say that object, it can be even your application. It's your app that you create at the beginning of main function. And you can set, and for example, it's your objects, some objects. And you can set application as a parent to the child objects. So after program is ended, then everything is deleted for you, and you don't have to write delete this, delete, and I mean you don't want to delete everything, all the three objects. Qt makes everything for you. And one more advantage is that the fact that everything in Qt is QObject gives us a very easy way to cast objects to certain types. And if an object has a different type from the one you want to cast, but inherits the same class, then you actually can do it. And here in documentation we have a wonderful example. When you like here, for example, let's assume my widget inherits from QWidget and is declared with the QObject macro. We will discuss what is QObject macro later. And you can create it specifying the type QObject, and then you can cast it to the QWidget, because everything is QObject. And like if you take a look on this example, if you, for example, cast it to the QLabel and it is not the same, for example, just label is 0. And you have less problems with casting your objects because you have one base class that is called QObject. And now I know I just gave you a huge amount of information, but now let's open the editor and see how it looks like in the code. In this episode, we're going to make a simple task managing console app. It is simple, but you'll be able to see how QObject and core concepts work. By the way, you can find the full code in the GitHub repository, and the link is in the description, of course. As you see, I opened the editor. In the previous episode, I showed you how you can create your project, but now I want to create a separate project for this episode. So let's hit create project the same way as we've done it before, Qt console app. I'll name it the same way, tutorial to video, and use default. Here specify CMake, skip, skip, and skip. And you have your project. As we created our project, let's right click on the name of your project and hit add new. Here we want to choose C++ class, because I want to add C++ class, of course. And it will make us header and source files. So let's name the first class as task. Here in base class, let's choose QObject, and as you see, include QObject and add QObject macro is also checked, as we selected base class. And here let's capitalize header file and source file names. Then hit next and finish. The first thing I should mention is that if you take a look at the cmakelist.txt file, you'll see that names of just added files were added to add executable function. If you, just for the testing purpose, comment those names, files, and you save it, wait a bit, as you see, files won't be added to the final build, and you won't be able to see them in the project structure view in the editor. You see here you have only main CPP. So let's uncomment it, and it should be here. Now let's go to the header file and see what is happening here. The first two lines and the last one have to deal with macro called task_age. If you haven't seen a similar code previously, you're probably confused and don't understand why they added. The thing is that include directives, when you, for example, here write include and task, this line of code, this include, are being replaced with the actual code on the preprocessing step during compilation. So it means that if you write include 2 times, for example here, or it can be in another file, and like 2 times in your project, in a complete project, then the code from that class, from the header, will be pasted 2 times, and your executable file will wait more. So using this technique, with defining a macro and checking if it exists or not, we just avoid multiple copies of the header after the preprocessing step of compilation. We also, just interesting stuff that we also can replace it with the pragma once, and it will work the same way. It makes the same as done it before. But if Qt suggests us to make it in that way, then let's just leave it as it is. Then you see the actual class declaration. It inherits QObject class and has that one QObject macro. That is macro, if you hover your mouse over, which allows you to use all goods of meta object compiler, such as, for example, signals and slots. We can delete it for now. After the macro, you see the constructor with an optional parameter, because you have default value, optional parameter called parent. I previously mentioned that objects organize themselves in object trees, and this is actually it. We have parent, and if you go to the source file, you see it just takes it to the QObject constructor. So okay, let's add a little bit of our code, just so you know what we are writing. We'll have two classes, task and task manager. The task will contain a description property is completed, like boolean, that shows us is it completed or not. A method to complete the task, and a signal that will be emitted when task is completed. And meanwhile, the task manager, that the second class that we will make, will contain list of tasks, like list of those objects, add task method, and complete tasks method that will complete all tasks inside, and a slot to notify when a particular task is completed. So okay, let's start. I will start with the private section. I want to add here first this QString description. I also have to include QString. And of course, I forgot. Here I also will change the constructor, because we want to receive a description, because it is required. Every task should have description. And here let's also change it in source file, and just description to the description. I'll just assign it. Then you see here prefix m. Why I use it? Because it means that it is member variable. It's the kind of naming convention. And also boolean m completed that we assign to false as we create our object. Completed to false. Fine. And also let's add the getters for our private properties. So just QString description, I'll copy it just so it quicker, and bool completed. So we can get description in this completed from the task manager. Of course, we have to implement it. I know it's one line, but let's make it correctly. So if you right click and go to refactor, you can add definition to task CPP. Of course, you can do it manually, but I prefer that way. And here we just return description. And description. Also the completed, and return completed. Before we add methods, method to complete it. Let's also add, okay, let's leave it in the public section and create one more section for the signals. Here, I know if you come from the just pure C++, it's strange for you, but why it works? Because we have QObject macro. That is the reason why we can write it like this. I'll show you more deeply later after we run program first time. And the signal that we create is with task completed, and we pass here string description. Of course, constant, because we don't want to change it in our slot that will be connected. And that's all what you need to do. I know it seems like it's method, but you don't need to implement it. Signals are just signals. You implement slots. And the last step left for us is to add and implement complete method. Refactor a definition, and here if task is not already completed, just to validate completed, then we assign true to the mCompleted. After that, let's write message QInfo, as I showed you in the previous episode. It's like the easier way to write something. And of course, we should include QDebug header. Of course, you can use also QDebug or wherever you like, but I prefer here QInfo. And task completed. And let's also output description, so we know what task is just completed. And after that, the interesting part is that we should emit task completed signal. When we emit it, all signals connected to this, all slots connected to that signal will be called with a parameter, with the argument we pass in here, and it pass here description. Okay, fine. Before implementing the task manager class, I want to start with something simple and show you how signals and slots work on the lower level, So let's jump here in the main CPP file. I'll delete comments, and let's create two task objects. So task1 is equal to task, I don't know, buy groceries, and let's specify as a parent our application. Here we should put a link to it, just to not leak memory. And when we specify it parent, we don't have to add that one delete statement at the end. We can just skip it, and memory won't be leaked. And second task, let's say fix bug. Then let's just call complete, and the same with the second task, complete. But now if we run it, nothing interesting going to happen. You can see I run it, and as you see, just task completed, nothing interesting. Okay, now let's add simple function and make it a slot to the signal inside task, and make it slot for that one signal. As you see, we had that parameters. We can receive it. So copy that and go here, void on task completed, for example, and put parameters. Arguments, sorry. And here, let's also include one more time Qdebug to write some message and Qinfo. Let's show that it's our slot. Task completed. Description. Nice. So to connect signal and slot, we have one function, static function in QObject. So we can write QObject and call static function, call it connect. Inside connect, there's 5 overloads, as you see, but the simplest one that we'll use now is just when you pass task 1, so the first object, and pointer to the first object, and link to method, sorry, not method, but signal. And then you just pass name of the slot that is connected. And let's do the same with the second task. And as you see, we can, to one slot, we can connect those two signals. And now it's more interesting because if you run your program, wait a bit, it's building, and you see here, I hope you see it. If not, now you see it. Task completed. It's message from the task class here, and then slot task completed. So our slot was also called when we emitting signal. Slot is called. We connected it right here, and as we have some code with the meta object compiler, I can show you what QObject macro is actually for. I mean that one macro right here. If you open your directory where your project is located, for example, here's mine, then you can see your, of course, files and build directory. Let's go to the build, debug, and here your build. Let me make it bigger. Inside you can see underscore autogen folder. Go ahead, click it, and here the most important files are that one, Mox compilation CPP. I'll open it. It opens in the Visual Studio Code, and what it's doing is including that file. So if we go here, we can see the actual file with the mock underscore and then name of our class. So if you open it, you can just take a look for the interest purpose. As you see here, warning, all changes made in this file will be lost, and it is not recommended to make some changes here. It makes no sense, but just to take a look, you see here names of our object, of our signal, of parameter we pass in. It's the structure here. Then you see some metadata, and that's all what is interesting about it. And I will show you later that for every QObject class, a separate file is made. So for the task manager, there is also gonna be separate file with mock underscore something. Now let's implement the task manager class the same way. Create, add new C++ class. Here I'll name it task manager object, and here let's capitalize also. Next, finish. Fine. Like the same way you did it with task. And as you see, we also have it in our CMake lists.txt. Okay, let's jump to the header. As you see, structure is the same. And first of all, let's rename to the private and create QList with task pointer to the tasks, and name it task tasks. Of course, we have to include the queue list and include task.h. It's just containing the list of tasks. For now, you can think of queue list as of just a list from the standard template library. We'll discuss Qt containers in one of the next episodes, so don't worry about it for now. Now I want to add slot to notify when task is completed. And here are public slots. In the same way, I mean, you probably didn't saw that keyword before, but QObject macro allows us to do so. And void qstring description. Fine. And now we can add the methods to add task. Task. And complete all tasks. Now we have to implement it, and of course, as I said before, slots are also have to be implemented, because slots, it's as in this example, it's like function. In our case with task manager, it's gonna be method. Let's refactor. Let's add all definitions, and in the task, we're gonna just first thing is task set parent to this one. So we want to build that like actual parent children tree. We would build it hierarchy. So not everything is the children of application, but I mean children. But I want to just build it hierarchy, you know. And then connect. And now it's interesting because you see, before we called a static method of QObject, but now because we are inside the QObject, we can call it just as it is. And now it's a bit different, but it will make sense. So first of all, you provide pointer to the object, then link to the signal, task completed, then pointer to the because this is actual pointer to our object that we are in now, and pointer to the slot, and now it's connected. And mtasks append task. Fine. Then in the complete all tasks, let's just make for loop and task and tasks. And here task, let's just call complete method. And if when we call it, then mCompleted is assigned to true, and a message is written, and signal is emitted. And when signal is emitted, then our method, sorry, not method, our slot will work, will make something. We will just write message. And here the same as we done it in main. I'll just copy it and make a small change, just not just slot, but task manager. And that's all I want to change here. So now let's jump to the main CPP. I will comment everything we have written so far, because it's another example. And then let's write here. First of all, I want to make task manager object. So task manager equals to new. Oh, sorry, I forgot to include it. Don't forget to include it. And here we provide as a parent A. of course, to not leak memory. Don't forget to do that. And task, let's just copy and paste. Let's make 3 tasks, just so it have some difference. And name it more simple, just task 1, task 2, and task 3. You see now warnings, but they will go as we finish our code. Fin manager, then we're adding it. And oh, sorry, here I copied and specified as a parent application. But now let me show you one interesting thing. Here, as you remember, we set parent, so there is no sense to specify parent here, because parent is also set when we add it. Okay, task manager, add task 1, then copy and paste task 2 and task 3. After it, just complete everything with our method. And after we run, let's see what is happening. What going to happen, sorry. Task completed. And where is message from the slot? Oh, sorry. My mistake. I just put the wrong method. I should put here on task completed. Sorry. And now you see everything is fine. So task completed, then task manager, task completed. And as you see, the signals and slots are working fine. And if you open your directory, as I said before, you're gonna have separated files for your QObject classes. So everything is fine, and I think that's it for today. I hope you understood this part, because it's really important, and see you in the next episode. Hi everyone, in today's episode we will dive deeper into QObject and all Qt related OP. We will look at QObject structure, all of that, and extend our knowledge about parent-child relationships. As you remember from the previous episode, QObject inherited objects build a parent-child hierarchy. See here, QObject organize themselves in object trees. It helps with memory management because objects can cascadely delete themselves without much effort from the developer. I already created here an empty console app, and now let's take a deeper look at QObject header. Let's create a new object. I will call it just obj, and also I want to delete all comments because we don't need it right now. QObject. And let's see what's inside it. If you hold Ctrl and right click at a type name, you can see that header file. If you don't have much experience in C++, probably header files from some libraries or frameworks look scary to you. But don't worry, I will show you where you actually should look at. QObject starts here with the QProperty macro for an object name. When we will start the QML journey, we will talk more about this property and how it works. But for now, you should know that it just creates the property with the getter to read, with setter to write, here with the signal and the slot where when property changed. If you scroll down, here I noted for me. Here you see, we can see the getter for a parent, so we can get parent of object. We can also see at line 201. The getter for the children list. Each QObject stores pointers to its children in QObject list. As you see here, the type. Here it's type. Okay, and the crucial thing I should point out here is that there is no copy constructor. By that I mean it is, but not public. So it can give us some problems in the future, and I'll show you when. So the copy constructor is, of course, the one that takes an object by value, not like a link or pointer or something, just by value, and copies everything to a new object. And since each child in a QObject can have an arbitrarily large collection of children, it is easy to see when copying QObjects is, why it is not permitted. Because if one object gonna have 5 children and each of those children have 5 more, then copying it could be slow. Here there is more different methods. The main ones, it's like set parent or find children, find child. But now we'll write example, and with that example I will show you how we use them. Here's the deadline. Of course, full code from this episode is in the repository. A link is provided in the description. And if you want to follow along, then start it now, because later I'll extend the code that will be written now. I want to create class here, new class user. Let's copy here and here. It adds to make lists txt, and for now I want to just create the class with the username property. So string username is gonna be getter, and here let's delete and private string username. Oh, sorry, and include string. In the source file, just add definition and return username. It's easy. And also we have to change constructor to specify, to specify username. And when someone wants to create a user object, he have to pass username. And if you remember, in QObject we have that object name, and it is not assigned automatically. We can assign it just for our purpose to check it later. So here I want to just set object name. It's method from the inherited from the QObject, and just Q name. Now they're gonna be the same. Now to show you what lack of copy constructor gives us, I want to create a function in the main file, print user. Of course, it would be better to create it inside the class, but just to show you when lack of copy constructor can give you issues, errors. Include user, class we created earlier, and here I pass it just as a value, not pointer, not link, just as a value. Okay, and when we pass as a value, object is copied. And here QInfo. We also have to include QDebug to use QInfo and output some data. And here let's do it like this: user info, and then the object. If you don't know what T does, it's like a tab, like 4 spaces in the console. You'll see when I'll run up. Object name is just user.object name. Let's go to another string so you see it. And the same with the username. Username. Okay. And in the main function, I want to create 3 users. So user1 equals to user. I don't know, user1. It's username. Oh no, most oftenly usernames don't have spaces, so let's pass underscore. And I'll specify also parent to not lack memory. Sorry, leak, not leak memory. User2 is we will create pointer to it, so we will create on heap user user2 and the same. Sorry, the same. And the third one, let's name it user3 and specify the same. Oh, and okay, sorry, I forgot. We have to, of course, use new operator. As you see here, we can have the memory leaks, and I want to print user. Print user. Call the function. First is user1, just passed by value. Second, print user, but here, because we have pointer to it, we have to use that asterisk operator to pass the actual value. And print user3. And as you see, we can't actually compile it, even compile it. We got 3 compile errors, say call to implicitly deleted copy constructor. It means that we can only pass our QObjects as a pointer to avoid copying. And we just can't compile program like this. Now let's make it correctly. So we pass it as pointer. And here we use that one operator. And let's also show the parent. And it's the same thing. Parent. Let's use parent object name. Then I also want to print out all children names. So here we can get inside Q object list. I use lint to avoid copying. Children, and we should include it also. Object list, and then with the simple for loop, iterate over it. We'll talk later about containers and the method inside some like QObject list, all that. But for now, I mean, it's obvious what method called length returns. returns just length of the container, I mean number of children's inside it. And okay, info child. Let's also give a something like index to it, and to not start it with 0, because I is firstly 0, we add 1. So we're not gonna get 0, 1, 2, 3, but 1, 2, 3, 4. Then object name. Okay. And now we can use it correctly. So here I pass it as a link, and here just pointers. As you see, we don't have any errors, warnings or something, and we can run it and see our output. I don't know if you see it good, but you see object. What? Object name. Okay. Object name, username, parent. Just to test, we can specify here user1 as a parent. So you see, parent here is user1, and here child number 1 is user2, that one. And we can do similar here, for example, and just we have pointer, so we don't have to use operator. As you see, child 1, parent. That's how it works, and everything is deleted after program has finished. We'll create a little chatroom program, and it will be the main example in this episode to wrap up new information. Remember that we made task and task manager classes in the previous episode, and we built a good parent-child hierarchy and set task manager parent as an application. There weren't memory leaks, but now I want to cover the situation when our kind of manager think class doesn't have a parent. First, just to make some good example, let's add the signal and slot to the user class, and signal is gonna be message send qstring sender username. I pass username and not just user, because later I want to show you one more interesting method inside QObject to find the child. QString. Then public slots. Message. Okay, I have to add definition to user CPP and just emit message sent signal, username and message. Okay, then I want to add new class called chatroom. Make it QObject. The chatroom will have add, remove, and send message methods. But we'll also implement the structure to clear everything from user list in case the chatroom won't get a parent, as I said. I don't know if you see. I hope you see. Okay, so first constructor we have it, then add user string, then remove user, then destructor, and let's make a slot. We don't want signals here, just one slot. It's a private one. When on message received, sorry, received. So here we get the same as sender username and message. And also we need a private section with the Q list. It's like this simple container, don't worry about it. We're not gonna use some hard methods, just add elements. It's the same as it's the same list as you know from the STL. I mean, very similar. Okay. So include the Q list, include Q string, and include user object. Also, let's add the definitions. In add user, we just create new user. New user equals to new username. And as a parent, I specify this chatroom object, because when chatroom is destroyed, then the users from the user list should be deleted. And connect. We connect signals and slots. So here I specify user message sent. It's our signal. And then we specify this object. So previously, as I said in the previous episode, I think we first specify that object with signal, then our object with slot, and link to the slot on message received. And we have to, users is the list we created, and append. So we add new user to it, new user. And also I want to here include qdebug, include qdebug, and write some message. Write qinfo, username, join the chat room. Then the second method is remove. So we just remove it from our list. And let's go like this. And here we have username passed. We need to iterate over all list of users and check whatever username is matched or not. So for user, here I use just for each loop, but we can use the easier one with from I equals to 1 to if user username is equals to username provided in parameter. Then let's also QML it. Just not join it, but left. Okay, m users. Remove one, and remove one just removes element we provide. And also to not leak to memory, delete user from here from memory. And we can return to not to just end our loop. And I don't want to use here break, because if no user with that username is found, then we should write some message. So is not found. If you just break the loop, then this message will be written. But if you return and then all method gonna be ended. Then we have the structure, and here is the interesting one, because see how we clear the list at the destruction stage. First, I use qDeleteAll function provided with Qt, and this function deletes objects, but not clears it from the QList. So later we have to call also QUsersClear to not leave dangling pointers. So as I said, we do it because qDeleteAll deletes object but leaves dangling pointers in the list. So we always have to clear it. If you skip clear, then the list will be left with elements, but users have already been deleted. It's the problem. So first I qDeleteAll, then clear. Let's go to the main function and test what we have written. Let's comment it out because we don't want this example. I want to include just chat room, because chat room includes user, and there is no sense to include all two things. So chat room. Then chat room, let's add, for example, it's just a string. I don't know, Alice and chat. Sorry, not char, chat. Bob. Then we can to send some messages with the help of that signals and slots we specified in the user class. We should find the user object, and to do this we can call, let's use just autumn. First is Alice equals to chat room find child. Find child method is provided from QObject, and here we can specify the type, and here just write username, because it searches it with the object name. An object name I specified it here. So when we pass to add user Alice, let's go to the chat room. Here it goes to the username in user object, and user object set it as object name. And find children finds it with object name. Okay, and the same with the Bob. Maybe let's do with capital letters. Okay, and if it found it, so if Alice then Alice send message and send hello. I don't know, and if Bob found it, then Bob send message hi, and at the end just a test method for remove. We can remove just one of them. The username Alice, and user left for us is Bob. We can also it's one Alice and one it's just ABC, not an existing user. So we will get a message it's not found. And as you see, chat room doesn't have a parent, but we did not leak any memory because here we have destructor and deletes and clears everything. Let's run it and see the output. Oh wow. Wow. I have error. You know what? I was in a little bit hurry and forgot to write definition for on message received. I'm sorry. Let's do it right now. It's small definition, so we just queue in for the sender, username, and message the sender wants to send. And now, if I run it, then you see all output correctly. So Alice joined the chat room. Here when we edit it, then Bob joined chat room. Alice, we found Alice and found Bob. Alice sent message hello. Bob sent message hi, and Alice left the chat room, and we've tried to remove also not existing user, and it is not found. But we didn't leak any memory because in the destructor deleted and cleared everything. I think this is it for today. In the next episode we will discuss smart pointers, and thank you for watching and see you in the next episode. Hey everyone, in today's video we will discuss smart pointers. I will start with what it actually is, then cover cases you most likely use it, and finally show how to use all types of smart pointers given by Qt framework in code. But what it actually is. In simple words, smart pointer is just a wrapper for a row pointer with the garbage collection. There is no single smart pointer type. As you see, we have many of them, but all of them try to abstract a row pointer in a practical way. A smart pointer, by comparison, defines a policy to when the object is destroyed. So still you have to create the object, but you no longer have to worry about destroying it. Qt framework provides us a wonderful way to manage memory with the QObject relationships. And you're probably curious why we should use smart pointers. When your class inherits QObject, you most likely don't have to use them, because it is going to be overkill. But sometimes, when you develop Qt apps, you can eventually need to have a row class. That is not inherent in QObject. And this is the case for using smart pointers. So, okay, I want to start with shared pointers. Shared pointer, shared data pointers, and Q explicitly shared data pointer. Because it is not hard to understand, and you will see how in most cases smart pointer types differentiate. And also the main purpose of those last two is to help shared ones. So you have to know it. Okay, let's start with Q shared pointer. And it is the most general of those three. You have here a lot of methods. I will show you an example. And it behaves exactly like a normal pointer for normal purposes, including respect for being constant. QShared pointer will delete the pointer it is holding when it goes out of scope. Provided no other QShared pointers, the pointer objects are referencing it. Or with simple words, it helps us share access to the same object and becomes deleted when it is out of scope. So let's write quickly a few lines of code as an example to start shaping your understanding of smart pointers. In this example, we'll create class with the constructor and destructor to see when they are called. So class, I will call it just my object with public section, my object as a constructor, and it's gonna be just, let's include qdebug, and also let's include qshared pointer. I'm gonna be qdebug, and my object is created. And also let's copy and paste, just make it destructor when it destructs. I suggest row it. And I also, no, I don't want to make anything. Let's delete comments. In this episode, we're gonna have a lot of like small examples for all types of smart pointers. So I will make functions for it, and they will show the scope where pointers are located. And of course, all code I will write today is in the GitHub repository, link in the description below. Okay, wait, let's name it E1, then E2, E3, like example. Okay, and in this example, let's create QShared pointer of type my object. You have to, if you know smart pointers from C++, then it won't be hard for you. You have to specify here in template type. And we provide new my object without any parameters, because only constructor we have is without parameters. And as I said, it can share access. So the second one is going to be also qpointer my object, and it's ptr2 equals to ptr1. Okay, but it's not pointer, it's like just object. No, and I make in the scope this example one because I want you to see when an object destructs. So, and notice one thing: we make two variables, but with only one object. Here, if let's add new property qstring, just qstring, let's name a, doesn't matter really, and ptr1, we can access it with this operator, a equals to, I don't know, abc. And then if I q debug a, but it from second one, we will get the same. Here, if I call it e1, let's run. And as you see, object is only one, but we have two pointers. So it behaves like a pointer, it shares access, and that's how it works. And at the end, it destroys it. Under the hood, it stores reference count, and while it equals 0, deleting object. Most methods are self-explanatory inside, if we go here. But the most important ones are get and just data. Let me show you it here. Get and data. Just return value. Value is our row pointer. Just return it as constant. Then important one is clear. Here we have clear. It just drop in the reference, and maybe here we have reset. It calls just clear, but also have 3 overloads. So in the simplest case, it just calls clear. But it just resets smart pointer to point to another object. As you see, the simplest one just clears. And one more is swap, also important one. It swaps pointer to other instance. And notice that it marked as no except, and hence it very fast. Okay. Next smart pointers will look this pretty much the same inside, but will only add a new method or more overloads for old ones. All smart pointers are similar pretty much, but just add some new feature. The next pointer we'll talk about is Q shared data pointer. Here we have it. If you compare that name to the previous one, notice the word data added. It probably means that it cares about data more or something. The main purpose of it is implicit sharing with the copy on write, or simply co rule. It means that whenever two smart pointers looking at the same object and first is changing, then copy will be made, and changes won't happen in the second one. In the next example, we'll make a separated object because it should inherit Q shared data. Let me show you what I mean. We can probably close it, or no, we can just copy him because class is similar, but I just want to show you difference. And it should, let's name it my shared object, for example, and also rename everything inside. And it should inherit Q shared data. We should inherit object for the classes that is used with the Q shared data pointer and Q explicitly shared data pointer. It should be inherited. Okay, so let's make another function e2 and say that Q shared, and of course we have to include everything Q shared data pointer. Shared data pointer, my shared object, Peter1, we pass here new my shared object. Then let's say Peter1, the string is equals to ABC. Then let's make two more pointers, and Peter2 gonna point to Peter1, and Peter3 is gonna look at Peter2. Okay. Then let's try to change value in Ptr2. And let's say A is equals to, I don't know, QE, just random characters on my keyboard. And then let's qdebug everything that we have. So Ptr1, A, and then copy and paste second and third. Notice here, look careful, we assign in the Ptr1 A equals to ABC. Then Ptr2 is equals to Ptr1, and Ptr3 equals to Ptr2. So they share the exact same object. So for now, they share the same object with A equals to ABC. But next, we assign ptr2 to a, to equals QE. And then if we print it out, let's see, sorry, I didn't call it. Here I call E2. And then let's see what we got. QE. Oh, sorry, my bad. It's I just looked at it and it looked just strange. Here we pass Q. Sorry, my bad. Q shared data pointer. Yeah. Now let's look at what I mean to. Here you see the second one is equals to QE, but first and third ABC. Why? Because as I said, the main purpose of the smart pointer is implicit sharing with copy on write. That thing is have simply a copy on write. If you ever saw co, it means copy on write. Okay, that rule. So here, when I changed value inside, it just made copy. And okay, now we will jump to the next one, and I will also notice how it do it, how it doing copy, and we don't know about it. And the next one from the shared category is Q explicitly shared data pointer. It is very similar to the previous one, but what means explicitly? Here we have explicitly. The thing is that whenever we change some property values in one of those two smart pointers, the touch method, we have here the touch method, and here we have the same in QShareData, the same one. Method is called, as documentation said, if the shared data object's reference count is greater than 1, this function creates a deep copy of the shared data object and sets the pointer of this to the copy. What it means is that, I mean, here I read from here. So whenever we share data with more than one pointer and data is changed, then this method should be called. And when we do it with Q shared data pointer, it makes it automatically. To see all of it in action, we'll write a bit bigger program with Q explicitly shared data pointer, and then quickly rewrite it to use the previous one, I mean that one. So you will see the difference. And now let's create new class, but I don't want to separate methods to the source files and header files because methods will be really short. So I will write method implementations in the header, just not spend time. Employee data. The first one I will name class employee data. And here let's include everything we need. Q share data, include Q string, because for the first one, this employee data is gonna be just a class to store employee data, and it will be Q share data inherited. So Q string, and also we will need probably Q debug, I think. Okay, class employee data inherited with Q shared data public. Then let's write constructor, and okay, before writing the constructor, real one, and it should be public, of course. I want to make properties. The first one will be ID, then QString, let's say name. And here, the empty one, we'll just specify ID as -1. And let's write message qdebug employee data is created. Then the second one, it will be copy constructor. So from the previous episode, you know that Q objects don't really have copy constructor, but here it is not Q object, so we can make our things. Okay, it's gonna be constant order, and just here we should pass everything in. First is Q shared data. We should pass to the Q shared data constructor this other. Then ID is other.id, and name is other name. So let's put it on the second line, and here also write a message. Maybe it's copied. And the last one is gonna be destructor. When we destruct, destroy our object, destroy it like this. And the next class we will create is actually gonna use this Q explicitly shared data pointer, smart pointer. I mean, names are long, it's hard. Employee. And here I will, let's create class without class not inherit anything, because there is class to like kind of manage the previous one we created. And here I want to include employee data, and here in public section, no, let's firstly in private create the main thing we here. It's explicitly explicitly shared data pointer with employee data, employee data, name it just D. And then we can make all constructors and all those things. Here's D equals to new employee data, just like this. Then employee int ID, where it's the case where we pass some data. Name, not pointer, sorry, just link. And here we say D equals to new employee data. Then as to set ID, let's create another methods. It's like setters for our smart pointer because it's private. And now set ID, I'm gonna have int ID, and let ID get ID equals to ID. As you remember, get method just gets the row pointer. And here we can call set ID. But let's make the same with the string, with name, with string. And I will show you where we made a mistake. Qstring, sorry, string name name equals to name. Okay. And here, as I said before, when data is changing, the touch method should be called. A QShare data pointer makes it for us, but in this case, we have to call it manually. So after we change something, we have to detach, call that method. So if two objects sharing the same object, copy gonna be made. Also, we can make quickly getters. So id it's constant method d id, and also the same with name, but here is qstring, and so d name. And also we can make the copy constructor for it. Employee and everything that we should copy is just a smart pointer. Then let's go to the main CPP and test it out, and I will explain you a bit more about what I done. Not employee data, just employee. And let's hide it and make E3 example number 3. So qdebug. Let's make messages just to know where we at. Creating employees emp1, and we actually created ID, I don't know, 1, 2, 3, and name John. Then qdebug, copying emp1 to emp2. Debug, and here we copy the same data, and then I want to modify it and show what will happen. So we modify emp1, and let's set e1 set name to the, I don't know, Bob. And notice here that those shared pointers are mostly used for internal implementation of implicitly shared classes. So what I mean by that, the most frequent use case where you use shared smart pointers, it's like how I done it here. I create one class with the data, and then one class with the smart pointer, and like for internal implementation. As you see, we manually call detach, and if we don't, then the object wasn't copied, and we will see only one message from the structure. Let me show it. So here, oh, no, I forgot to call E3. As you see, we have two messages when it's destroyed. So that means we have two objects, not one, and it was copied. So creating emp1, then it is created, it's message from the constructor, then copying is, then we modify. So we write employee data is copied when we set name. So when we set name, here see the detach. So the data was copied, object was copied, and then we get this message for the destruction 2 times. And if we change for and just so you see, for example, let's comment this when I call detach method, what will happen? You see, only one time it is destroyed, and so it is not really shared data pointer because we didn't call it. So explicitly tells us that we explicitly should call detach method, and if you want to remove it and not use that, you can just use shared data pointer, and it will work the same way. You can run, and it's all good. You see, two messages. But the important thing is that if you want to share functionality, functionality to work properly, you must call this get method. Okay, not forgot to use it when you change some data. The next pointers we will look at, just let me hide it, are QPointer and QWeak pointer. And names are not very fancy, so those are going to be easier. The first one is QPointer. Let's include it, QPointer. And even though we will only take a look at functionality and the most frequent use case, I think you should know that Qt in previous versions deprecated QPointer, then let everybody switch to QWeak pointer, then they removed QObject tracking capability from QWeak pointer, so we have to use QPointer. Okay, enough crying. The main purpose of the QPointer is a weak reference to a QObject. It automatically sets itself to null PTR if the QObject points to is destroyed. In simple words, uh, we can only make a pointer to QObject, inherited object, and we have to delete it before the point because the pointer is weak. But you'll probably ask, like, I mean, delete. Okay, just if my token is not enough explainable, you can only create. You can only point to the. I'll create QObject, my QObject like this, to QObject inherited object. And you also gonna need to write this delete thing and at the end. But why we use it? It does why if it exists if not give us garbage collection. And the thing is, pure pointers after deletion become dangling ones. So after deletion, we want it to be null PTR, and pointer just help us with doing this. Let me show you an example, and you will understand what I mean. So let's say public, as in previous examples. Okay, let me copy it because it will be similar. Just I will change this, and it inherits QObject. And I create its yes, example 4, and call it, just not forget later. Here, let's say we create QPointer to my QObject. obj new my object, and this okay, we can also yeah, let's quickly create change this constructor to pass, not take another line, just like this. Let's say BC. Then we create the second object, second pointer. That's obj2 to obj just. Then we can qdebug to see that obj get Okay, they are the same. It's like the same object. They also sharing it. And if you write here obj get a equals to, I don't know, some other things, some text, then and then qdebug all of this, you will see that it's also one object. And at the end, you should always write delete obj. For now, just let's run it. As you see, it's the same one object. And we delete it because, and why we use it, just why we use qpointer instead of raw pointers? Because when we write delete, obj is not dangling pointer, it's null ptr, and it's good. Like, you don't have to write obj equals to null ptr like with raw pointers, and then we can check it. So we have a method called isNull, and let's qdebug also. And if it is null, then let's write obj null ptr, and then the same with the second, not obj. Let's run and check. Yes, it is null ptr, and that is good. And if we remove deletion of object, memory will become leaked. So as I said, just do not make them dangling. The next one is qweak pointer. Here we see I go with list q pointer, qweak pointer, then gonna be scoped, but doesn't matter. Qweak pointer is a weak reference to an object managed by q shared pointer. Its main purpose is to observe an object without owning it. Let's say you have a shared object managed by q shared pointer. You have that one object with this pointer. And multiple parts of your code might share ownership of the object. Like here you have this pointer, here, in different parts of program. And it can create a circular reference. For example, an object holding a q-shared pointer to another object that also holds a q-shared pointer back to the first. You understand? Like, then it becomes circular, one to one, just. And the reference count will never drop to 0. And the objects won't be deleted, even when they should. To solve this problem, we have qweak pointer that can be used to break the circular dependency. It observes the object without increasing its reference count, allowing proper cleanup when the time comes. So if I want to draw it, let's paint. Here I have one shared pointer, here I have another. And like they can make circular dependency. With the weak pointer I can break it, and all objects gonna be deleted instead of making memory leaks. Let's write example for this. Now I will not use some additional classes, just with the integer. It will be easier. So void e5. Let's make your shared pointer with integer shared ptr is equals to your shared pointer with integer create, and just it's instead of calling constructor, we can do it like this. And then let's create qweak pointer Also int weak ptr is equals to shared ptr. Then we can check, just as in previous example, if weak ptr is null. And let's qdebug. The object is still alive. Then when we make shared ptr clear, let's check, sorry, Q, like this. Has been deleted. And let's call it. And everything works properly just as we expect. When we clear, it's deleted, like obvious, you know. But if we change cubic pointer to the qshared pointer, let's just try it. Here's what gonna happen. What? Why it is not deleted? And you can see that the object is not null ptr, and we left a dangling pointer, so we have problem. So in this case we can use qweak pointer just to delete it properly. The only two smart pointers left to us are qscoped pointer and qscoped array pointer. They are like to each other and not so hard, so it will be quick. Qscoped pointer provides us exclusive ownership of dynamically allocated objects. It means we cannot share access to the same object between many pointers. But the important thing I should mention is that Qt started to deprecate it to encourage us using unique ptr from the standard library. And let me show you what I mean in code. Hide the previous. And let's go E6. Here I want to include it quickly. Qscoped pointer and also qscoped pointer array, because I will use it in the next example. So qscoped pointer of my object, let's just use that first object we create, just empty, not inherited from anything. Have prints the, output to the console statements. Yes. And we create ptr new my object with some text inside abc. My object. No mention what? Oh yeah, sorry. Let's just create one more. Probably I forgot to edit. Just like this. And it will work. Okay, and as you see, if we run, we create and then destroy, as expected. But what if we want to move ownership to other pointer? Because, you know, if we want to like write ptr2 equals to ptr, ptr, then call to delete the constructor. We can't do that. The purpose of that pointer is that we can't share the ownership. I mean, we can, but we can. But if we want to move to the other pointer, like we can do it probably, yeah. And we should use ptr. Let's here ptr take method. If I do it, it will work, of course. Here ptr. Oh, sorry. It's like here, like this. Because take method, if you search here take, scope. Where? Oh, probably we don't even have it because I'll show you why. So you see, take is deprecated. Use instead use unique PTR with the calling release instead. And I don't know if a few days it worked, but for now, let me check. PTR, it's like, and then if I want to delete it, I'm just curious if it will work, because it should, even though it's deprecated, but should work. Yes, it worked. Okay. And to not get error, warnings, we have to use unique PTR from the standard library. So unique no, it's not, sorry, header called memory. Yeah, my bad. Header is called my memory. And here we can change to std. Unique PTR, my object, create, and then call the release. As warning suggested, release us. Yes. And if we run it, it will work. I know it may seem strange because Qt is a framework and why should we use standard library tools, but they want us to use more modern tools. And similar rules applied to the next smart pointer, specifically Q-scoped array pointer. The difference between those two is that Q-scoped array pointer manages array and accordingly deletes full array at the end. So we can write void e7 7 example. Here let's create Q-scoped array. Scoped array pointer to the main my object. It's called array new. And create with the line of 5. Let's assign some values to a. So int t equals to 1 minus 5 plus plus equals a. It's the text inside equals to, let's say, obj number, and we can use static method from QString. We'll talk about QString in depth in just just next episode. So you have to watch it, and we'll talk about all methods inside. So Q number on I. This we assign this text, and then I want to print it. So qdebug array I. Sorry, R. Like this. And if I want to take it, I will get deprecated warning. Like the same way I done it before. I even can copy str2, let's say like this, take, like the same way it was before. Maybe let's name it just R2 or row. Yeah. And here print it. And then of course delete. Delete all array. You see, it will work, but with warning. So to avoid it, we can use std unique pointer. Then here we need to use get method because unique pointer don't have overloaded square brackets operator, and here leaves like this. Yes, unique PTR doesn't have additional class for arrays, so we have to use get method before searching in info index. And let's run, check how it works. Sorry, it's I didn't even call it. Okay, sorry. Now I call the you can trust me. It will work with the take, but you're just gonna have a warning. And here, as you see, everything is destroyed without warnings. And okay, we covered all kinds of smart pointers, and I think this is it for today. I'm a bit tired. Thanks for watching, and see you in the next episode. Hey everybody, today we have such a comprehensive topic that may not be very hard, but it is huge and important. We will discuss the Q string. The one important thing I want to mention now is that Q string class is not Q object inherited. I will quickly show you. If I write here Q string and include Q string, and call constructor, then go to this class, it is not Q object inherited. So when I said that pretty much everything in Qt is inherited by Q object, I meant that those data storing objects are mostly not. So watch the full video, because I will explain most of the methods and it will save your time in the future. If you are very new to programming, the string is a bunch of characters. Each character is a separate object of the type qchar. Qt provides us a QString class, so we can easily manipulate 16-bit qchars. Earlier, we had already touched QString in previous episodes, but we have only created it and assigned it. Now I want to cover more useful methods, and as you see in the documentation, we have a bunch of them. But don't worry, sometimes it is even obvious what they are doing with the name. Okay, let's go through that list of public functions. Constructors have many overloads, but as you see, most of them are used for compatibility with other types of string, or just to copy strings. Like here you have this for compatibility, this also, because qlet in one string view and qbyte array is also representing strings, and we will talk about it in next episode. Then this one, it's also about compatibility. And the last one, here you have move and copy constructors. So let's create a few strings for testing purposes with the different kinds of constructor. I'll go to my editor. I hope you already know how to create project. I'm not how I'm sure that you know. And let's create QString. Let's call it str1 equals to just empty constructor, as I done before. So it just creates, we create str1 as an empty string. And then let's create str2 and pass here some text. In str2, we pass an array of chars, because as you see, the type here, no, you don't see it, maybe here, yeah, you see here, const char 10. The type here, one of possible is const char str, and there is pure C++ string. I would say like that, it's just pure C++ string. Okay, and let's also create str3, and here pass size and the character we want to fill it with. As you see, now we have also a constructor for that. Here we pass the size and character we want to fill it with. if you think about it, it may look strange because we pass pure char from C++, but the type in the constructor is qchar here. But it works because qchar has a constructor for char. Here I opened qchar, and you see, we have a constructor for char. Also notice here that Q6 type is a pseudonym for another type. Let's go here. No, I want to open here. I want to open this constructor, then Q size type. And you see it's Q integer for size of and this long type. Okay, and then let's print it all. So let's just create one helper function to print them. Print all, and pass here 3 Q strings. Okay, let's include QDebug to use this QDebug to output some data in console. Let's also write that star1. And then we just pass it. And let's see what we got. I'll increase the size of my output. And here we have it. First is empty string, then just some text. And the third one is 10a characters. The next method is append. So it simply adds a character or string. You see here we can pass character or we can pass string or other compatible classes to the original string. We also can pass this kind of string, and I will show you how to do it. Okay, let's go to editor and let's write, for example, str1 append. Just first is simple string abc, for example. Then str2 append. Let's test the qchar. And third one, I want to show you how to add this kind of string. And firstly, we have to create it. So it's gonna be const qchar. No, not this. Sorry, I mean this. Qchar c equals to new. We specify length when we create that array of qchars. That's, you know, B, C, D. And then we can str3 append C. And also, here, as you see, we should provide the length. But what if we give, for example, 2, not 3? Let's see what will happen. Str1, str2, and str3. Let's see what we got. And here is it only adds first 2, because when we create array, that kind of pointer thing with its array, we should provide also statically length. And if we give 2, then it will add only 2 of 2 elements of array. So the first one adds pure C++ string to the original Q string. The next one adds next one is adding 1 character, and the last one, for the last one, I create an array of qchars and append it, and I can specify how many characters I want to add. Okay, Oh, and also, I'm sorry, I pretty much forgot. Sorry, we have to, of course, delete all array C, because it's pure array and it doesn't have some garbage collection. So we have to delete it. Don't forget, because memory gonna be leaked. I executed it once, so I leaked my memory. Sorry if I leaked yours also. You have to delete it. Sorry, just sorry. And also, I want to here write some comments just to separate things, because of course code will be in the GitHub repository in the description if we want to compare or copy or something. Okay, constructor, then append. Okay, so next method, it's arg. I will make comment for it. And okay, this method has a bunch of overloads, as you see, a bunch of them. And I will show you how to use them, because this method is really handy. Okay, let's create new string called qstring str, just str, and write here name %1 age 2. Let's specify that it's in meters. %3. And here, this arg method is working with percentage and this number things. So on this place, some value will be inserted. And sorry, I talked and forgot. Okay, now let's try it. I don't want to create new variables for the results, so I will just debug it quickly. So okay, Qt6 C arg, and for example, we can specify it Bob, then 30 years and meter 80 here, one by one. So if I run it, let's see. Here I have name Bob, age 30, height 180. Okay, but if you want to pass other types, do this. Qdebug arg, and here we can pass first of all Bob, then arg, because this thing returns a string, and because of that I can output it. Then arg, I want to pass here integer, so let's go, and here I want to pass float. It's gonna be double, okay, because I can specify so it will be float, but it will be double right now. I can make it float like that. Let's start and see. Here I have pretty much the same result, because if it's double, then zeros can stretch. And SEC overloads for that are here. So for the char, int, and so on. Or in the first option, it worked because of that overload. Because of, sorry, this overload, I hope. Okay. The next, let's say, category of arg method is inserting a string, giving more functionality. So I talked about this. Here, let's see how to use it. Qdebug str arg. Let's say Bob. Then we can specify field width. Field width is just how many symbols will be taken from this string. Let's say here 5, just for some reason. And the last one is field char. So if this number is more than length of provided string, the rest characters will be filled with the thing that we give. So let's take a look. And here you see Bob. It filled like this because we specified 5. Okay, the next 4, I hope 1, 2, 3, 4, yeah, are doing the same things but with the compatible classes: QString view, Q1 Latin string view, and so on. I want to show you another one interesting. Let's go to the next line and arc. Let's say 120, 10, QChar. And I'll show what it does right now. This one is interesting because let's go here. We use this overload. And you probably understand what other parameters do, like integer a. Okay, we specify what we want to insert, then filled with, how many symbols it could take. Okay, I specified 2, so but 123. Okay, then base. Why do I put it here 10 and by default is 10? This parameter yes, you so called base, and it means the numerical system I want to be interpreted. If I put, for example, 8, then it will be octal. If I put 16, then hexadecimal. So let's try 16. Here we get 78. You are probably also wondering why I explicitly converted char to qchar, because the method has lots of overloads. So here has lots of overloads. We help the compiler to resolve them. If I remove it, we'll get error. So we help compiler to resolve it and know what it should use. As you see, we have similar types. For example, long is also, it's kind of like int, but longer, I think, q long, and so on. But what about double? Let's try to use it. Because we have one new argument, for no, not one. We have format and precision and what it does. Let's see. So in the same, let's go arg. And for example, just so you know how it works, let's put it like this. Let's start, you'll just see, then I'll explain. Okay, what just happened? One by one. It's not the correct way, what I showed you. Oh, sorry. Here, what we got? Double A. Okay, we gave double that we want to insert. Then field width. Okay, 6. It's more than, so we have here the minus. And point is also taken 1, so 5 and 1. Then G. I will now give you the full list of possible ones. G is just general format, and the number is displayed in the shorter or fixed point or scientific notation, depending on the magnitude of the number. I read it from what I know that so far I don't know that intelligent words, so I'll show you the full list what it does that I found. Okay, the next is precision. For it just about this. So if I, for example, put 1 here, what I get, it just rounded to this. So it does exactly it. Let's put 3 and it should be in correct way. Pretty much. Okay, we can put 4. And here put also 4. Because we don't want any minuses in our height. Okay. Because it's about this format. Okay, sorry. If you put 4, if you put F, you got it like this. And here, it's right. Okay. As you see, you can experiment a bit with those values. It's interesting with the floats. And okay, let me show you the full list of possible formats. I'll just copy and paste them. F, fixed point notation, number is displayed in standard way. In standard fixed point notation, just like this. Is a scientific notation. E is just like, you can see on example what it means. G, as I used, depending on magnitude. And G, the same D, but uses uppercase letter for the exponent in scientific notation, like this. Okay, it was a pretty long method. Let's jump to next. Assign method is used, as you probably guessed, to assign another string to our string. It, as you see, since 6.6, Qt 6.6, so it is brand new method, and you can notice here pretty strange types that we probably didn't saw earlier, called QAnyString view and not Q, just input iterator. Really, QAnyString view is simple utility class introduced in Qt 6.6 that supports all string representing types. You can think of like it's the same as, like, it can represent Q string, Q Latin 1 string, Q string view, and standard C++ strings, raw characters, character arrays, and so on. Input iterator is a utility that supports both Qt and STL iterators. Like, you have iterators in, for example, string, I'll show later, and iterators in vector in STL library. So it supports both. So let me show you how to use it. First of all, let's create, for example, just to show you how to use it with different types, let's create Q Latin 1 string view. Let's Latin str. Let's put here hello. Then let's create, I want to include string from STL, and I want to include a vector from STL. So let's create std stringus. And std vector of course, characters. So it's vector str. No word. And now let's try to use it. So str1, just str that we created earlier. I won't create new strings. I'll just use it in all our examples. First assign. Let's try QLatenString view. As it works, I mean, we don't have any errors. So let's qdebug it, str, and see what we got. Yeah, see, it works. Just hello. And then we can also assign this string from STL library, and it will work the same way. It works because we have this QAnyString view. It's beautiful. Let's see here, we have world. Then let's try to do this with the vector. So str assign. As you remember, we have a first iterator and to the last. And I think you know how to get iterators from vector. If no, just copy me. Begin and vext str and maybe just to test we can hit -1 just to show that iterators works. Iterator works. Let's try. Not word, just word. And just to show you that with our Qt strings, iterators can also work, let's do pretty much the same stuff with Q let one string view. Str assign and Q str. But from the beginning, let's make +2. We can make the same operations with iterators that we make with the STL iterators. Thank you, str and also I forgot to make comment. Sorry. Assign. Let's start and see if it works. See if it works. I don't output anything. Just so. Okay, here as you see. And if you don't know what iterator is, you can think of it as a pointer to an element or like to a character. Most iterators have addition and subtraction operators overloaded, so we can easily jump to near standing elements. It's a simple explanation, as quick as I possible can do it. Text method is at is used to get character on a certain position. But of course you can also use square braces operator. I'll quickly show you example so you know. And so we can just debug str on, I don't know, second position. We have here LLO, so we're gonna get O str at 3. If I run it, sorry, 3. Okay, now we have this error because index must be in the range from 0 to length -1. So if you provide wrong index as I done, you'll get an error. Now it will work correctly here. And but don't worry to also to use square brace operator. It works just the same way, as you see. Back gets the last element of the string. If the string length equals to 0, you'll get an error. So let's try. Let's kill debug. Steer back. And then let's just for testing purposes make the string empty with the length 0 and try to call it. We'll get error. Here as you see, assertion error. And in the first case, when we have something, it just gets the last element of the string. So I will comment it because I don't want to get any errors. Let's go next. We have begin. In one of the previous examples, we used it. So I won't explain iterators here because it is basic stuff and you should know it from some beginner C++ tutorials. But begin just returns as iterator to the beginning of the string, as we done it here. just iterator at the beginning of the string. Let me just quickly show you example. qdebug str begin. We can just get it like that, or let's make a second, and also let's assign something. I don't know, ABC. And we can of course get the value from iterator with the asterisk operator. As you hear, we just get place in the memory because it's pointer, and here we get value from this pointer. So the next one, we have here capacity. Capacity returns the maximum number of characters that can be stored in the string without forcing reallocation. Classes like QString dynamically allocate memory when the count of elements is bigger than capacity. It means that we have certain capacity. Let's say here, I will try to draw it. We here have some capacity. No, let's don't use title. It's our capacity. And capacity can be like this, but our string we only have this much data. That you can understand it in that way. So let's try it with our str. What we'll get? Interesting. Debug. First, let's write str just to see what we have, and then str capacity. Sometimes the numbers are not so obvious, you know. Capacity. We have ABC, we have already 3 characters, and capacity is 32. As you see in the output, we have 32 capacity, but the length is only 3. Why? Earlier, we assigned different values, and the longest one was probably here. Probably here we assigned the longest value. It was something like that. I think, yeah. And I don't want to count how many is it, but when the string grows, Qt typically increases the buffer size geometrically. It means that doubling the size or growing by a constant factor. I mean, it could be like length multiplied by length when we insert so many characters. Then C, begin and C end are not very interesting. They just return the same iterators, but constant ones. So I can let me just copy and paste example. So you see, it's really not that interesting. Here, just remove. I mean, you can use it that way. A constant iterator, as you heard here in name, we can't change it later. We here can say -1, but then we can't. And you see what we get. But don't forget here some interesting thing. First is cend, and we get null. So don't forget that the end iterator is standing on empty space. That shows the string where the end is. And to point at the last character, you should subtract 1. Here we have last character. Then we have chop. Chop removes characters from the end of the string. We can specify how many characters we want to remove chop. And it will remove. So let's say str is equals to ABCDE. Then str chop, let's say 3, and let's see what we got. AB. It just removes last 3 characters. And important thing that if you, for example, you have now lines 2, and what if you will write chop 5? Then pretty much nothing will happen. You won't get any error. It will become just empty string without any exceptions, errors, issues, crashes. As you see here, just empty string. The chopped method differentiates only in the thing that it creates a brand new string instead of modifying the old one. So here you see it returns void, but int, and it returns QString, brand new, a copy. Chopped, and let's say str is also equals the same. And then we can't just write it like that. We should, let's say, Qdebug, and inside it write chopped 2. And if I now Qdebug just the string, nothing will happen. Because, as you see here it chops, here not. Because it returns just a new string and not modify our. The next one, clear, as name suggested, just clear string. Let's quickly test it. Str clear. What will happen? It will clear our string, so we will get empty one. Yes, just empty string. The next one is gonna be compare, and compare is maybe a bit not logical, because how you can compare strings and get integer, but wait a second, I'll explain you. The comparison is based on numeric Unicode values, and it also can compare both case sensitive and case insensitive. You can specify it here. Case insensitive or insensitive. And let's write example. I will call static method this compare, because I don't want to create so many variables with string, so many string variables. And let's say x equals to string compare. The first one, let's make it equal, but with the different case. And here put case insensitive. So it should be equal. And let's Qdebug x. And of course you can also, if your str equals to this, then you can make it that way. It works the same. But here I want to use static method to just not create so many variables with those strings. And now, if strings are equal, the result equals to 0. And in other cases we'll see right now, but let's test this case. As you see, it equals to 0. And let me make more space. Then next, let's say y equals to QString. Compare and put here just auto car, and it will be Qt case sensitive. So now this one is smaller than that, so we should have something bigger than 0. as you see. So in other cases, other than that, it returns a negative integer if first string is less than the second string, and a positive integer if first is greater than second. So we can also test the case if, for example, the same but case insensitive. So now we should get negative value, as you see here, because now this one is less than this in case insensitive format. And by the way, if it is unlogical to you why we have, for example, here uppercase and here lowercase, and it's like higher, it's bigger. As I said, comparison is based on the numeric Unicode values. Here I opened a Unicode character table, and as you see, firstly we have uppercase letters from 41 to 5A. Then and only then we have lowercase letters. So they are standing higher in this table. In ASCII, it's a bit different, so maybe it's unlogical to, but comparison is based on Unicode numerical values. Okay, next we have const begin. Here also we have const end. They are the same as C begin and C end in STL. So, and they're also like here we saw already C begin. Yeah, we had C begin and C end. So they're the same. We can say that const begin and const and just equals to C begin and C end, and there exist these ones exist for STL compatibility, but work in the same way. So I think there's no sense to show example because you saw it already. Okay. Next, let's see. Const data. It's interesting one. It gives us read-only access to characters. This is the constant. So, for example, let's write const data. For example, I have str equals to hello, and then I want to get it, which are meaning that it's an constant array of characters. So const data, and then just to show you, let's iterate through that array and print it. So for in equals to 1 e as the necessary size. We have a size method just as in STL and I++. And I. Okay, let's see if it works. And as you see, hello. And also, if I scroll down, we have this method data. It gives us not constant array of characters. So, if you want to get this pure arrays, you can easily do it. Okay, and then contains. Okay, contains. This method helps us determine if the string contains another string or no. Also, we can use regular expressions, and also we can enable or disable case sensitivity. Okay, let's try. I will say that let's just we have hello, so use known by us method append, we used it, and append world, and that's all. Hello world. So let's, for example, if str contains rld, and then qdebug contains, and I want to here write, and I have to use the backslash, because otherwise I will get error, because the compiler don't know where string is end, where the end of the string. Str contain rld. Then let's test. I'll just copy and paste. For example, here we have hello, and let's also, just for clarity, qdebug our string, just to know what is inside. Hello world. Let's and also put Qt case insensitive, and because we have here in small case, but it also says that the string contained, because we put case insensitive. And I also want to show you an example of how you can use regular expressions in Qt. But in next methods, I want to show you this, because you know, they are completely separated topic, and if you want, then you can dive into it later. But really, it is so much to explain if you're not familiar with it. So let me just show you the example. So here we have hello world and our string, and then we can create Q regular expression. Let's name it rare, and here just to find it. And also let's include regular expression and regular expression match. Those types we want to use. And also I'll show you, we're gonna have a warning, and I'll fix it and explain why we have it. Q regular expression match. So we have our regular expression and match. Match. It's like container for strings that are matched. And let's say if str1 str contains our array, and we should provide match. As here we provide regular expression and pointer to match. Pointer, not link, as here. So because of that I use this operator. And if it contains, let's qdebug match, capture it. First one. We have here this warning, says don't create temporary Q regular expression object, you use static. And that means that we have to create it in static, because in most cases we create regular expression one time and then use it, and we don't want to recreate it. Okay, but I have some mistake. And yeah, here I should it be here because what be doing is use it to denote a word boundary, and we use this use this backslash just to use this one. It's like how the string works. If you want to use a double slash inside string, you should also give before that one. And this b thing ensures that world is matched as a standalone word. And if I try it, I'll get world. And the next method we have here is count. And it provides us a way to count the number of occurrences of string in string. So, for example, let's write some example count and say is there equals to xo xo, and then let's count it. Count equals to str count xo x, because I want to show you one thing. Debug count. Here, as you see, we have 3. So let's count 1, 2. And as you can see, uh, it also counts overlapping ones. So be careful with that. It counts it like that. 1, then 2, then 3. So with the overlapping. And it also have the case sensitivity and regular expressions. Let's use case sensitivity, for example, Qt case insensitive, and maybe let's add one more x at the end. We have 4. And the next ones are C begin and CR begin and CR end. And they're the same STL compatible iterators as before, but here we have reversed, and this means that you can traverse string from end to the beginning. This is that. So next is data. I mean, as I told you before, the same as const data, but here you can both read and write. And then and is obvious you can get end iterator of the string. We talked about it earlier. Then ends with, and it's more interesting. It's used to determine whether a string ends with it or no. And if let me show an example. And with, for example, if str ends with x o and put here case insensitive, then we can Qdebug contain. Oh no, ends with, not just contain, ends with. And as you know, because here we have it like that, so x like that, ends with. Okay, fine. And you also have method pretty similar to this. Let me find it. Starts with the same, but not from the end, but from the start. Okay. And where we here. Then we have arrays. Arrays, we can use it to remove some characters from different parts of the string, providing iterator pointer iterator that points to where to start and where to finish, or just single iterator to what character we want to delete. And let's try. It's str equals to abc d e f g h, and then str arrays from str begin, or let's use c begin. It's more likely we have to use here c begin because we have const iterator. We should provide it. Let's say +3 to move it 3 places ahead, and then strc and -2. And what we will get is qdebug string. As you see, we moved 3 places, so it's standing like here, and then to the end -2. So it's standing here. So from here to there, we remove DEF. And let's test also arrays if we put, for example, str cbegin, only the beginning one, for this overload right here. And I think you know what we will get. Just remove a from the string. Let's move here we have fill. Fill doesn't have any overloads, and we use it to fill the full length of the string to the character we provide. For example, str fill, let's put a. So if I debug it, I have a because length is 4 and fills the full length of string with our character provided. Next one is first. We have two overloads, and it returns a string that contains the first n characters of this string. But don't use it if you are not sure the number you provide is less than the length. So let me show you what I mean. First, if I, for example, qdebug str first, I don't know, 2, it will work okay, and I will get AA, as you see. But if I, for example, don't know how many characters inside, just in case, and put 20, I'll get error. Let's see. So in this case, if you're not sure if you're not sure the number you provide is less than the length, you have the separated method called left, and it here. Let me also test it quickly. Left. It won't throw you errors and just get AAA. And next method is index of, pretty important one. It returns the starting index of a string or character inside, and it search forward from index position from, so we can search for like next occurrences. Let me show you what I mean. Index of, and let's say it's the name of some file, my text file. txt, and let's qdebug, just qdebug, str index of and this match string. For example, let's search for txt. As see we have txt. Let's put here also. Here txt and here. So firstly, it will get us, let's see, this index 2. Yes, so the starting point, starting index of this internal string that matches. But we also can provide this from where we should start searching. For example, I'll put here 5. So it searches the 10th occurrence in this string, and that's pretty useful. The next one here, insert. It inserts a given string to a specified position and then returns the reference to the string with newly added characters inside. So we can write something like insert qdebug insert. I don't know. Let's put here. First, we have to put index, the position where we want to insert it, and then I don't know, some asterisks. And it returns us a reference to newly added characters inside. So if I just give the qdebug string, I'll have the same as you see. It inserted us this string inside. Then we have is empty, is lower, is null, and so forth. It's pretty obvious what they are doing, and is empty and is null are similar, but the difference is visible when we compare a string with an empty string with no value at all. So what I mean by that? Here is empty, is null. For example, if I qdebug str is empty, what I will get? It's obvious that I will get false because we have some value here. But then I write str and put and assign to it empty string. And then what? I'll get true. But if I call str is null, qdebug it. I'll get false. Why? Because empty string is not the null. And when we will get true is if I, for example, create null str, let's say it, and not assign it anything at all. And then if I qdebug null str is null, then I will get true. And that's why this exists. You see, I get true. And this last thing. Then we have is lower and then is upper. And it just checks if all characters are in lower or uppercase in the string, nothing more. Then is right to left. It checks if the text in string should be written from right to left based on its content, because in some languages we write from right to left, not from left to right, but reversed, like from right to left, and it just checks it mostly for displaying in parts and how we properly should display it in our GUI. Then we have is valid UTF-16, and it ensures that the string does not contain any invalid surrogate pairs of for invalid code points for UTF-16 encoding. It is pretty rarely that you have something invalid for UTF-16, but sometimes if you have to validate, you can do it with this method. And I have last and also first, where I don't remember if we covered first method. First, where it is here. Yeah, we covered it, and it works the same as first, just from the end. So as you remember, where we have it. First, yeah, here. It gets first values, some some number of first characters in string. But in our case, last, yeah, it works the same, but from the end. Then last index of works the same way as first index of. So first just index of, where index of, but from the end, exact same way. Then we have left, and yeah, I think I showed you before, but it returns a substring that contains n leftmost characters of the string, and the difference is that first, and the difference with this first method that I showed you before is that it won't throw an error if you give not valid argument. Just quickly, I will show one more time. Debug. str, and we should assign it, or not, let's not assign. Okay, let's assign. I don't know, so maybe C. Here we go left 10. So it gets n leftmost characters from the string and not throw an error if you go out of scope. The next one we have here is left just filled, and it returns a string of a given size that contains this string packed by fill character. And if truncate is true and width is less than length of string, it will delete the remaining characters. Let me show it in the example. Left just filled. So let's say we have something in our str. Let's maybe add more to it. Oh no, it's good. Okay, let's say str equals to str left just filled because it returns new string, and here provide width, I don't know, 5 instead of 3 that we have here. Then fill character, I don't know, asterisk, and truncate false, so we can leave it as default just. And let's see what we'll get. So as I said, it returns a string of given size that contains the string packed by the fill character. So you see, we provide this length, and if it is bigger than size of our string, then the remaining characters will be filled with this fill character. But in other case, if, for example, here we provide, I don't know, 2, what we'll get? Let's see. We'll get the same, and sometimes you want this behavior, sometimes you don't, and because of that we have this truncate false or true. by default it's false, but here if I specify true and provided with is less than size, then string will be truncated to the specified size. Okay. The next method, length, you will use it all the time. I think you understand what it does. It just basically returns the length of string. And just to make it more interesting, let me also show you how to iterate over this string. So let's assign ABC, D, and then I can iterate over it. I'm less than str length, just constant value of, sorry, not constant value, it's constant method, returns as Q size type. I previously showed you there is pseudonym for other type. And here let's Q debug I. Either we can use add method or str add method, or more frequently used curly braces operator, and get it by index. So we get A, B, C, D, E. So what we have next? Locally aware compare, it's very similar to the compare one, it's not really important. Max size, it's also very abstract thing for mostly embedded devices. The mid, it's more interesting ones. Interesting one. So let's see. Let me show you what it does. And mid is very similar to the method called first that we previously saw. But here you can provide from what index to start. I mean, here you have first, and you just start from the beginning. But in mid, you can specify from what index you want to start and where to end. I mean, it's not where to end, but rather just size of string you're getting. Let's say mid. And for example, here I have 2 and 2. CD, because see, we how these parameters are called position and n. So we put position to 2 and we start here, and then we go 1, 2. It's like the size of internal string we want to get. We're getting it. Okay. Then I have normalized. It's also not so rare, not very frequently used. Then prepend. No, if you see, it has a bunch of overloads, mostly for the compatibility, but pretty important. I mean, pretty useful rather. Prepend. As the name suggests, it adds a new string or character to the starting of the string. So previously we just get the starting of the string, and now we can add to it something. Let's say, I don't know, 3 dots. Then we will get new one. Like this, we just prepend our string. Then what we have is pushback. Pushback is the same as append, just for the STL compatibility here. Push front, same as prepend. The same way, just for STL compatibility. And begin, we discussed it before. Then remove. Remove is more interesting because here you have 2 ways to remove something. First is specifying some string or character, and it deletes every occurrence inside your string, or you give index where to start and the count of characters you want to remove. And let's test it. so remove, for example, here I have the string, and for example, I want to delete dots, or okay, let's just delete dots, and maybe here I will add a new one, so just to show you what I mean by every occurrence. So it's string, it's not like character, and it should delete all of that. As you see, it deletes every occurrence inside a string. And the second way is str remove. We give some starting index, let's say 1 here, and I don't know, 3 count of characters we want to delete. So we're left with AE because we start here 1, 2, 3, and left is AE. Fine. The next ones are similar. Remove add just removes at certain position. I mean, it's obvious. Then remove first and remove last is also pretty obvious. But one important thing, just so you know, remove first, remove last. Here, if you, for example, we have 2 characters, you remove first, then let's say remove last, and then one more time you remove first. And how do you think should we get error or not? But with this method, if string is empty, just nothing will happen and you don't get any errors. So it's useful sometimes. Let's go here. Repeated. So by the way, and the same as here, just for STL compatibility, reverse iterator to our string. Repeated. So repeat returns a copy of the string that has been repeated the specified number of times. For example, repeated. I say, for example, str equals to text, and I will add space, and then str repeated, let's say 3 times. Then I can debug it, because it just returns a new string. And I have here text, text, text. Okay. Next one. Here you also have replace. Replace works similarly to that remove. I mean, the functionality is similar. You provide in similar values, but really it just not removes, but replaces those occurrences. So I think it's obvious what it does. Let's say, I don't know, a quick example. Str we have here text. I want to str replace. First I will specify before, so it's gonna be text, and I want to change it to maybe just char. No, wait. Yes, I can just throw here a char. It's just a character. What will get a. But here we have some logical mistake, because we assign text to it, then repeated it, but this the result of repeated method. We didn't save it to our string. So because of that, inside string we have only one text. So it is a returned. And if we want to fix it, let's just assign str to this repeated, and then debug on str. So let's see. Get a. Fine. Then the next method, reserve. It's pretty obvious, and you've not really use it. It just reserves some space and capacity of string. Then one of interesting ones, it's section. You frequently can have situations where you have to separate the string and then just get the section of it. And this is exactly what this method is for. So let me show you example. Section. For example, I have str equals to some pass in our file system. It's root, bin, the users, my file, txt. For example, I have something like that. And then you want to get a section of it. So separate by slash and then get section of it. Most times what most programmers will do is use something like split it to array, and then just get by index, or maybe instead of that they will try to make loop, then check whatever it equals to slash, and so on and so forth. It's easier here if you know this method. You can just specify separator, okay, slash, and then put here start point and end point. Let's say first example, I get 1, so it gets just bin, and you also can specify qstring skip empty. You can section skip empty. You can skip or just leave it as default. Skip empty means that if you have something like that, it will not take empty one. Let's see what we got. As you see, we just get bin. And if you want to get bigger section, you can specify, for example, from 1 to 3. I'll get bin users my file txt. And it's really pretty useful and can save your much amount of time not implement it by yourself. And then we got set num, and you will use this method so many times, I promise you, because it converts number to string and has a bunch of overloads for different types of number. Let's see. Set num. For example, I have number 1, 2, 3, 4. And you want to str set num to num. So here you want to convert this integer to string and assign this new string to our str. After that, you can, for example, debug it and see it works. 1, 2, 3, 4 in our string. It's pretty useful, and you have a bunch of overloads for different types, also double float and so on. Then what is really interesting, simplified. Simplified is pretty interesting because it removes some symbols like simplified, and it removes everything like this, all those symbols inside string, and also white spaces. But not just white spaces, but I mean, if you have many white spaces, it will become just one white space, like simplifies string. Okay, so let's try. Here, for example, put 2 white spaces, text, then /t, some other stuff, and then /r/n. But you want to just get your text with 1 white space between them. So you can use str simplified, it returns new string, and then if you could debug it, you see it removes this, it removes also that, and just put 1 space between instead of those all symbols. Then we have one of slice is pretty much the same as mid. So next we have split. Split is interesting one. As I talked about it when I written this example. What it does, split, it just splits our string and put it in the list of strings. So for example, I have 1, 2, 3, 4, and you want to separate them. So you can write qstring list l equals to str split and by comma. And also, if you have something like this, for example, you can specify skip empty behavior. Then we don't have to write loop because using the QDebug, we can just make it like that. And we see 1, 2, 3, 4. It's so nice, I think. And then starts with works pretty much the same as end with. We talked about it earlier. Then what about the interesting ones? The interesting ones are this to int, to long, to lower, to short, to std string, to use short, and maybe to upper. Probably to upper. Where is it? To upper. Yes, those are all to convert string to other things like number or std string, or maybe just to lowercase string or uppercase string. Let's test it quickly. So let's say to float, to std string, and so on. You can write, for example, str equals to 1, 1, 2, 3 point, and convert it to float. So if str equals to str to float. We also can specify here, as you see, okay. Here, interesting is base. I talked about it earlier in arg method, what is based and why we sometimes want to use it. fstr, and you'll get just float. Yes, or for example, str equals to, I don't know, abc, and you want to make it all uppercase. So let's qdebug and str to upper. The upper, and it's all uppercase. Maybe what is left for us, what interesting, maybe trimmed, sometimes useful if you str, for example, you have something like this and you want to remove not needed spaces from the beginning and end, you can just write trim it. And you see it removes all unnecessary spaces from the beginning and ending. Then you have operators, some static methods that you can read about. I think I showed you pretty much everything you need about this, about string. In the next episode, I think we'll make some small project or just discuss QString view and QByte array, because this is also related to string. But I think it is it for today, because this video is also pretty long right now. So thanks you for watching, and I hope I will see you in the next episode.